Okay, so welcome to tonight's session, and I'm glad that you've tuned in for this. So what we're going to look at tonight, particularly with the weather getting a little bit chilly now, we're going to start looking at what sort of measures we can take to protect our installations from frost. So we're not looking so much now at customer comfort. This is more about the nuts and bolts of how we make some protection. And given that the Digistat I have here is reporting 12.5 degrees, or actually 12 degrees, it's sort of an apt thing to do. So I might have to get some heating in here before long. So what we'll look at is we'll kick it off with I've got a little video montage here I can share with you. Now you all know that our Digistats, the programmable stats, and a lot of our kit has already got frost protection built into it. That is to say, air frost protection. So this is ideal if we've got a system where there's no pipes that run outside, everything sort of runs within the sort of fabric of the building that's on the whole heated, then you can say that having frost protection on your stats is enough. And for the majority of cases, that will be fine. As we go through, I'll take you through some oddballs where you may have to take a two-stage frost protection approach. But for the majority, the built-in frost protection that you get on our devices will happily suffice most homeowner. So we'll kick off with the Digistat. So this is a programmable Digistat. This happens to be a +2 RF, but it's just as applicable for the +3 as well. Any of the programmables where you're dealing with time and temperature, you can see here the minimum setting that you can set on the Digistat is 5 degrees. So it doesn't matter what the customer does, what we can read 5 degrees as is off. So when we're doing our temperature setting, we set an on period would be something around 19 to 21 degrees, depending on what sort of comfort level they want. But the off, then, if they wanted to go into an off period rather than go to a setback, we can't turn it off with a Digistat. What we do is we set a low temperature, and 5 degrees is the lowest temperature. And therefore, if the temperature inside the house drops below 5, which obviously, if that did happen, that's quite significant. You know, it's going to kick the heating on, and it's going to keep it at that 5 degree level. So you can read 5 as off, because in most times you're not ever going to get to it. So as far as the customer's concerned, 5 will mean that the heating goes into an off period, and they're never going to drop to achieve that unless something goes wrong, in which case it will kick in and hold it at 5 degrees. So that's true of the programmable stats, the Digistat +2, +3, doesn't matter whether it's wired or RF model, or if it's the 3-wire or 4-wire stat, it's the same. Now remember, with the Digistats, when you turn the temperature down, the temperature that flashes at you is the set point, and once it's set, it will then revert back to showing you what the ambient is. So in this scenario here, 17 degrees is our ambient temperature. We know we've just set it to 5, and we know there's no call for heat because there's no little flame symbol on the left-hand side of the screen. So that's now set at 5 degrees. We happen to be in the auto and manual mode here, which means we've just set an advance for the time period, and then once the time period expires, it will go back to following the schedule. But we could have just as easily put it into manual mode, and then it would be 5 degrees forever. Or indeed, if you went into holiday mode, it would be the same. So if we move on and have a look at Wiser, well, Wiser is exactly the same sort of principle. So here's a Wiser system that I've got set up here, and you can see we do call it off. So when you're going through the carousel, you've got now, it doesn't just go to 5 degrees, it does go to off. But the reality is that there's no difference between the 5 degrees and the off. They're exactly the same. So even by setting it to off, you still do have frost protection, which will kick in at 5 degrees. And that works on both the carousel, your scheduling, but also here when we're looking at away mode. So you think of away mode is the way that you would set a blanket temperature across all of your zones for when you go away, either by you initiating it, or if you've got it integrated with IFTTT, that's how you would get it would drop into away mode. Even if you set it to off, you've still got frost protection there. So the off in this instance is really just there for the customer's benefit, who they want, if they're adamant they want to be able to see an on temperature and then they want it to go off, we've got the off option there, but that does not override frost protection, which kicks in at 5. So 5 and off are interchangeable. It's just there to make it a little bit more user friendly for the customer when they're setting their schedules. And remember, you'll be setting schedules across all of your zones. So if it's just one room thermostat for like a thermostat kit with your ISA, then you'll just have the one zone. But for every single zone you can have up to a maximum of 16, you'll be able to go in and set what you want your temperature to be, which, if it's for frost protection, will be 5 degrees. So let's now consider a more traditional system where we've not got any sort of time and temperature, and there's no programmability going on in the one device. We've got this format, which is a time control and a temperature control. Now, this happens to be a 2-channel, but it could quite as easily be a single channel, so a single channel timer going to a room stat, which off then to a combi boiler. This setup would be more for your biflow and twin zone systems, but the principle holds that these two devices are wired in series, and in order to get the boiler to fire, we need the programmer to be in an on condition on the right channel for central heating, and the room stat needs to be calling for heat. So the switching, both of them need to be made in order to fire the boiler on. Now, you may say, well, what's the problem with that? Because you can see here that the room stat will go down to 10 degrees, which is, it's never going to freeze if you set to 10, which is true on the thermostat side. But remember that all the programmer does is on and off. So it just looks at the time base. So it's not looking at temperature. And if the programmer is in an off condition, it doesn't matter if the room stat calls for heat, the boiler won't fire because it's being held off by the programmer. So remember, 2 switches in series, both need to be made in order for the boiler to fire. So for this sort of scenario, we haven't got any frost protection as standard. So what are our options with this? Well, the options are that we could add an air sensor, and I'll show you that in a minute. What I will also say is our TRVs, and a lot of people might not know this, but our TRVs have also got some frost settings. So here you can see on our TRV4, there is no hard off position. If you wind it all the way down, you get to the star, which is frost. And again, that's set between 5 and 7 degrees. So if you go into a room and that you don't use very much, you think, well, I'm not using it, you throttle it all the way down, that room's never gonna freeze because you can't set it any lower than frost. And that's why if you're gonna remove these, or if you wanna remove the radiator off the wall, you can't rely on just turning the TRV down to frost in order to cap the pipe. You do need to take the head off and install the decorator cap. So that's just something to be mindful of, but it's there as a safeguard. So everybody does it. I'm not using these rooms, so they throttle all the TRVs down without really considering what happens in worst case scenario should we start getting any freezing. So that way you will hold the temperature between 5 and 7 degrees. Now, if we take a look at an RT212, which is sort of at the entry level, this has again got the frost position. So you've got your 6 positions, and then you can turn to frost. So again, exactly the same as the TRV, but just a thing to be looking out for on these, you can go past the frost setting on this to the 0, and the 0 is hard off. So in the 0 position, you don't have any frost protection. So again, just something to be mindful of if you're throttling down rooms that you don't use very much. So in terms of an electrical solution for our frost protection, we've got this, which is our RTS3. So it looks very much like a room stat, and it is in essence identical to an RTS1, your standard dial room thermostat. It's just that the temperature scale has been changed on it. So you can see here your setting is between 3 and 10 degrees. And if we just have a look at the back of that, you should be able to see that this is a side-by-side comparison of the RTS3 and the RTS1, and the wiring is exactly the same. So it's a mains-powered thermostat. It requires a neutral, permanent live, and the call for heat. Now, the reason I say permanent, and this is where we depart slightly from the RTS1, is remember the RTS1 is fed by a programmer, so the 2 need to be in an on condition for the boiler to fire. What we want with a frost stat is we don't want it to be held off by a room stat. Alexa, stop. 3000, 2000 tests. Apologies. Let me just dispose of Alexa. That's that. So back to this. So if we have a look at the RTS3, it's a permanent live and neutral supply that goes into it. So that will allow it to not be held off by any other time control. So the way you would wire this is your live that goes into it is going to come from exactly the same place that your programmer gets its permanent live from. So you don't want to be going on any outputs of the programmer. You want to be going on where it actually gets it from the source. But other than that, it's an electronic thermostat. So again, you don't get any clicking. If the thing's not energized, you turn the dial up and down, you're not going to get any clicking, because you can see in the top there where the relay sits. It's an electronic device. It does need that power on those first two terminals to be able to run. And then you see the only possible output you get is 3, which is the mains power coming out. So if you're looking at volt free, you have to be a bit careful with this, particularly if you're looking at this for combi boilers. You need to make sure that you're going onto the right side of the combi boiler if you're going to do this, because you don't want to be going into the 24-volt side. Otherwise, that's a new PCB, so that works out to be an expensive day. Now, if we take a bit of a deeper look at this, we were looking at the air side of it then. And like I said, if you've got all of your pipes running inside the house or inside the airspace that's being heated, then it's not too bad to just have that extra stat, the RTS3. Maybe you would put it in, say, a porch or a conservatory, or maybe one of the coldest places, so that when the temperature in there drops down, that's when it will kick your heating on, and it will just hold it at whatever the temperature is there. So you've essentially got your existing controls, your timer and your room stat, or your program and your room stat, wired in series, going off to the valve, but you've now brought in an RTS3, a frost stat, in parallel with those controls. Now that's fine, like I say, if everything runs inside the house. But what we need to look at now is if you start having parts of the installation maybe run outside or run into an unheated portion of the house. And that's where we would want to not only look at air temperature, but we want to look at what the temperature of flow is in the pipe. Because after all, it's the water in the pipes that's going to freeze if everything goes south. So we need to be looking at the air temperature, but we also now want to look at what's going on in the pipe. And this is where the pipe stat comes in, the PTS1, and you can see it's a clamp-on device. You've got your temperature scale around the side, so you can choose anything from 10 degrees up to 90. Now this is a bimetal thermostat, so it's very much like a HTS3, a cylinder stat, in so much as there's no neutral required. You don't need any. It's just a 2-wire in so much as it's a live in and a live out, based on what the temperatures you've got around the dial there. And you can see the little yellow flag in the top right. That allows you to fix the temperature. So the principle here is you set what temperature you want on the return. And remember, this needs to go on the return. There's no point putting it on the flow, because the flow will get up to temperature straight away as soon as the boiler kicks in, and then it will knock off your frost protection. So you want this to be on the return of the pipe, and it works in conjunction with the HTS3. So like before, we had a timer and a room stat together, and both of those need to be in an on condition in order for the boiler to fire. With the 2-stage frost protection, the air stat and the pipe stat both need to be calling for heat in order for the boiler to fire. And then if any one of those becomes satisfied, and it's most likely, if it's in an unheated area, that it will be the pipe stat that becomes satisfied first, that will then kick the boiler off. So what we're ensuring here with the pipe stat is that the temperature of the water in the pipes doesn't drop below whatever we set on that dial. And in order, because it's obviously quite critical to make sure that this doesn't accidentally get changed to a different setting, you've got the little yellow flag in the top, which allows you to fix that position. So you make your setting, and then you fix it, and then the dial can't be turned without actually disassembling. So then we'll have a look at the back of the PTS1, and you can see it's got the little V shape there, which is designed to go for your pipe to run through the center of that V, and it's held on with this coily spring. So you've got quite a bit of scope there for the size of pipe work that you want to go on. Now, this is not going to be accurate to like within half a degree like our digital stats. It's going to have a bit more of a swing on it than that, but again, it doesn't really matter, because what we're trying to do here is ensure that the pipes don't freeze. We're not looking at precisely setting a comfort setting for the customer, and that's why it can be a bimetal control, so you can afford to have that bigger swing. But consequently, it's a simpler control to actually wire up. So I'll just take you through now the terminals inside here. So you can see there's 4 terminals. Now, one of them is an earth terminal. It's one of the few controls that we make that is actually class 1. It's not a class 2 control. It's got the earth there going to the chassis. But I'll just show you here. If you go across terminals 1 and 2, terminal 1 is your common. So when you turn it up, it makes, and when you turn it down, it breaks. So that's the configuration that we would want. But you do also have the other side of the contact where you can have it so that when you turn it up, it breaks, and when you turn it down, it makes. So you can see it's quite a versatile piece of kit, this, based on the flow temperature that you've got in the pipes. So now we'll have a look at the backplate of the RTS3. So again, this is all standard wiring that you would have for an RTS1 or any other mains-powered room thermostat that's electronic. You've got your permanent neutral on the left, followed by the permanent live, and that's where it sort of goes away from standard wiring, because normally you wouldn't normally bring a permanent live into a thermostat, because a thermostat normally is always fed from a programmer, because the two work together to give you the time and temperature. But here we've got to make sure that there isn't any other control that holds off this system being able to work. So permanent neutral, permanent live, and then terminal 3 has got the switch wire that goes out, and ultimately what's going to happen is that switch wire will then go through the pipe stack and on to whatever it is that we're going to drive. In our case, we're going to drive a motorized valve open. But that's how we should have it, and you can see it's a 5-core cable. We're only using 4 of the cores, so one is just snipped back, and we've got the little brown flag on there to indicate that that is a switch live. So just worth doing that just for the next person that comes along after you to understand what's going on. So that's how you would wire that. And then in terms of the PTS1, this is how we would wire that. So earth to earth, you've got the common going in onto number 1, and the output is going on to, it looks like it's going on to 4 there, but it is actually wired to 2. But again, here I've used a 3-core cable, and I can do that because I don't need the neutral for anything else. So I've just indicated the neutral with the flag to show that it is a switch wire. But you can see there that the output that's come out of the terminal 3 on the RTS3 goes into terminal 1, and as we saw before from that little demo, as the temperature increases now, it will kick it in, and 2 will go live, and that will then be sent back down on that blue wire. And now here's the wiring diagram that supports that. So you can see there, RTS3 heads the part of that circuit. So permanent live in, core from 3 out into feed the PTS1, and then terminal 2, it takes it across. And what you do then with terminal 2 on the PTS1 is quite important. Now, I've seen a lot of times where people will take it to the orange wire of the valve. So I'm talking here in terms of, say, an S-plan or a Y-plan or a bifloor or twin zone. And the problem with that is, yes, it will fire the boiler up. So just by livening up the switch live of the boiler, that will fire it up. But the problem is that you're not opening the valve. So you're not going to get any flow through the circuit. And that's what we need to get. And you could say, okay, well, maybe I could do it on the hot water side. So can I open the hot water valve? But again, that's fine if you've got a vented system. But if you've got something like a megaflow in there, you've got the other valve in there, which is going to hold it off. So you're always better off dumping it. So what you're essentially doing is dumping the heat from the frost protection circuit into your radiator circuit. And that's what we've done here. So terminal 2 from the PTS1 goes into the same. That's possible, but remember that if we set the PTS1 to something like 20 or 30 degrees, it's not going to be radiating any heat to the room. So it's going to have limited effect on the actual rooms that have got radiators in. But what it is going to do is it's going to get some flow going through the system, and as soon as the pipe stack comes up to temperature, it's then going to knock off. So, and the way that it doesn't do that in the summer is because we've got the RTS3, the air stat there. So the air stat, temperature drops below the threshold of what the air stat is, and that will mean that the RTS3 will call for heat. Now, if the boiler's just been firing and we've got, say, 50-degree water in the system on the return, then nothing's going to happen until such times that the air stat remains below what it's set at, and also the pipe stat drops below whatever the setting is on that. And I normally set them at about 20 or 30 degrees, at which time the boiler's going to then kick back in. We're going to send water all the way around the system, but the pipe stat is going to kick it off when the water in the return gets up to whatever it's set at. So you can see you're not going to be wasting heat, because you're burning just the right amount to be able to keep the water in the pipework at whatever you set the PTS1 at. You're not causing any, or you're causing minimal, I would say, sort of unnecessary heating in the room, because the water's never going to get up to the sort of temperature that it's required to be able to heat the home, and consequently your boiler's probably not going to be on for very long. So that's really the principle of two-stage frost protection, and it's really required in a scenario where you've got pipework or anything that runs outside of the building where it's in an unheated space. And here's a bit of an example of a system that I went to once. I particularly went to it to have a look at the Wiser system. As you can see, there's a Wiser hub in there. But all this here is actually outside of the property. It's in like a sort of makeshift boiler house, which is not ideal, but you've sort of got to work with what you've got. But you can see here that there's a lot of pipe work here that is outside, and there's no means of heating in this outbuilding. So we've got the two valves there. So this is an S-plan system, or a twin zone system. But you can see here on the return. Now we know it's the return because on the extreme right we've got the magnetic filter. So all the before it gets back into the boiler, it's trapping all of the magnetite that's coming back through the system. And then we've got the PTS1 there, and I believe it's set to something like 20 degrees. Should be a close-up on that in a minute. There's the close-up of the RTS. So you can see RTS is set more or less on 5 degrees. So as the air temperature drops below 5, that will kick in. And then the PTS1, you can see there, is set at 20. So when both of those conditions are met, air temperature below 5, return temperature below 20, that will kick the boiler in. It will start, the pump will kick in, because all we're doing, remember, is we're just opening the valve. So exactly the same as what we would do if we went to turn our heating on using the timer and the room stat. But this will kick it on until such time that either the air stat gets satisfied, but in this scenario here, because this outbuilding isn't heated, it's highly likely that the return temperature will be up to 20 degrees before the sort of radiant heat and the convection from just the pipe work alone gets to the RTS3. So that's sort of the end of the demo. And really now I just want to know if you've got any questions on that. I appreciate it was quite a brief sort of demo, but there's not a huge amount to talk about here, because particularly if you're using something like the Digistat, then it's already built into it. And like I say, you only really need this two-stage frost protection if you're running pipes into an unheated airspace. You could say belt and braces. It's a good thing to do for all systems, but I would say that for many it's overkill. But certainly you want to get something in. So just a programmer and a room stat on its own doesn't offer you any frost protection. So for that scenario, I'd be looking at trying to get an RTS3 in somewhere, maybe in, say, a conservatory, or somewhere where you've got pipework that extends, but it's within the main body of the house, so it does benefit from the heating, generally speaking. So you can get away with just an air stat. But again, if you've then got pipes that run in somewhere, particularly maybe into a loft or something, or if you've got an annexed building and you've got any run of pipe that goes outside or through a space that's unheated, then that's where you would want to start to employ the PTS1, and you would get then your two-stage frost protection working in tandem with the RTS3. It's a bit of a shorter session tonight, but I hope that that's clear. We have had a couple of questions on frost protection, and it's not, we don't sell a huge number of the PTS1 and the RTS3, but it's quite a nice thing to have in your arsenal in case you come up against something like that, where you need to make sure that a particular run of pipework isn't going to be susceptible to frost. So we'll just see if there's any questions that are going to come in. I don't see any at the moment, but as always, these videos will go up after the session, and they're going to be live for as long as I'm around. So you'll be, any questions you've got, just stick them in, and I'll do my best to come back to you. Just as some housekeeping, there will not be any training, at least from me anyway, next week because I'm off. But just keep an eye on the Drayton community Facebook group to see what else is coming up. I'm going to have a week off and hopefully try and get some last-minute autumn boating in, and then we'll be back then for November to kick off some more training, where we're going to start looking at how we interface Wiser with heat pumps. So we're going down the sort of renewable route. And again, any of your sort of suggestions. So if there's anything you want to see me cover, even if it's stuff we've done already, by all means, drop it in the comments, and I'll do my best to sort that out for you. So I don't see any questions, and most people have dropped off now. So I'll just finish by saying thanks for joining me as always, and I'll catch you soon.